Hello everybody, very big welcome to this evening's lesson. It's a small audience tonight because I forgot to send out a reminder email for this evening's lesson, but perhaps also because the maths is perhaps also because the maths is so horrible. But I'm sure this is a select audience of people who are right on top of it. Belle Wu says she loves the front cover image. That's fantastic. I'll tell you a terrible secret. It's an old front cover image from an old lesson that I've reused because I didn't have time to do a new one, but don't tell anybody. Fantastic. Wonderful to have you all here. Belle also says the first person to say what they had for dinner gets a shout out. If only I had already had my dinner. I don't know, I'm going to have to work out what I'm having for my dinner when I go downstairs after I've cleaned up the cat sick that I didn't get to before this lesson. Okay, brilliant. Fantastic to have you. And of course, if you can't get enough of my teaching, you should join my online classes where you can actually interact. Go to my website, the link's below the video. All right, enough of all that. Let's get into having a look at the lesson. I need to scroll to the top and I also need to open the right page. There we are. Okay, and this question is an absolute nightmare. It's really difficult. Somebody says, can we see Dimitri? Dimitri is downstairs doing Dimitri things, hopefully not being sick anywhere else. So unfortunately I don't have him with me right now. But you're right, I should bring Dimitri and Greavy up more often for the start of these lessons. Belle says the math was kind of hard. If it was only kind of hard, then you're doing well, because I think it's very hard. Okay, I have two model cars, which I call Fiesta and Corolla. Yeah, good starter cars. Each car is programmed to drive at a constant speed. Okay, so it always goes at the same speed. When you set it going, it keeps going at the same speed. When it hits an obstacle, so it hits something, crashes into something, it reverses its direction, so it goes backwards and travels back at the same speed. Okay, so that sounds straightforward. But you read that and you think, well, hang on a sec. When it hits an obstacle, it probably won't go straight back. And you might also think, when it hits an obstacle, it's then going to take a little while to get back up to speed, and maybe it's going to bounce and all that kind of thing. So the next paragraph deals with that. It, as so often with maths and mechanics and physics, it simplifies the situation in a way that makes it wrong, but allows us to do some maths with it. So you should assume that no time is lost when a car hits an obstacle and reverses. So there's no point at which it's stopped, or which it's bouncing around, or at which it's going more slowly as it gets back up to speed. It just turns around immediately and immediately is going at the same speed backwards. The cars are very small, so you should also assume that each one has zero length, or an infinitely small length. I don't think I expressed that very mathematically. But the basic point is, you're not trying to work out whether the front of the car hits the other car, whether the back of the car hits the other car. Each car is just a point, and they either hit or they don't hit, which is not like real life, but it makes it easier for us to do maths. I place my cars in a square arena. It's like a tray or something, which has sides of length 1 meter, like this. Okay, so here's one of my cars and here's the other car. Each car starts exactly halfway along its side. So this distance and this distance are the same, and this distance and this distance are the same. It's very important that when you read a complicated question like this, that you take the time to work out what everything means in the way that I'm explaining. If you don't, you're at risk of messing the whole thing up, or just getting very confused. And it's positioned so that it will hit the opposite wall at a right angle. When it reverses, it will follow the same path in the opposite direction, which is a complicated way of saying that Corolla, for example, will just go there, and then there, and then there, and then there, and then there. Oh, not like that, the last one. And it won't sort of start veering off like that or anything like that. It'll just go up and down on the same course. For each of the following situations, so it's going to be more than one. You need to calculate how many seconds will pass before the cars collide, so crash into each other, or state that they will not collide. So we're trying to do two things. We're trying to work out whether they're going to hit each other, and if they do, when will they hit each other? After how many seconds? So it's a fairly simple requirement, but it can be tricky to work with. Tops 8 has said, guys, if any of you feel like you won't pass, don't worry. After I wrote the exam, I thought I failed, but I didn't, so don't fret. Of course, not everybody would pass their 11 plus, or the exam wouldn't exist in the first place. But there is a really important lesson there, which is it's almost impossible to tell how you did in an exam when you walk out of the door. So do the exam, and then don't worry about it, and wait to find out what happened. You might think it went really well, and you didn't go well enough, or you might think it went terribly, and in fact you got in. And I've counted loads and loads of children who have been in either of those situations. Good advice, thank you. Right, okay. We are dealing with distances, such as 1 meter, and with times, such as seconds, and we need to find out how many seconds, that's a time, and we're dealing with speeds. So we're dealing with speed, distance, and time. Now, I'm not going to spend ages on the basics of speed, distance, and time today, because there are other videos in which I've done that in a simpler way. And if you go to my video list, you'll find, for example, there's an Easy 11 Plus short lesson from years ago in which I go through all the basics here. So if you don't know what I'm about to say to you, if you haven't seen this stuff before, go there. We're going to start by drawing the speed, distance, time triangle, which looks like this. S, D, T. Okay, it's a triangle like that, like a warning triangle. And between D and these, there's a dividing line, and here there's a multiplying point. And what we do is, just quick revision, whatever we want to find, we cover that thing and we do the others. So if we want to find a distance, we cover it and we do speed times time to get distance. If we want to find a time, we cover it and we do distance divided by speed. And if we want to find a speed, we cover it and we do distance divided by time. And that's going to be really, really useful for us here. So we're trying to find how many seconds will pass. So if we want to find a time in seconds, we do distance divided by speed. I'm just going to note that to the side. T equals D divided by S. Really, really helpful to have that in mind. I start with cars moving at a speed of 10 centimeters per second. Right, so the first question is, where would the cars collide? So let's look at the diagram here. They're each halfway along each side, which means that they're each 50 centimeters from the edge. And that means that the point where they would collide would be exactly in the middle. It can't be anywhere else, because if Fiesta is over here, then it isn't going to collide with Corolla somewhere here, and vice versa. So the point where they'd collide would be in the middle. So the point where they would collide would be 50 centimeters from there, and 50 centimeters also from there. And then if Corolla, or let's stick with Fiesta actually. I'm going to stick with Fiesta because that's going to give you a good basis for the other questions. So because Fiesta tends to be the slower car in the later questions. So 50 centimeters gets us to the middle, or another 100 centimeters gets us back there, and then another 100 centimeters gets us back there, and so on. So let's think about this. Let's just look at Fiesta. So Fiesta distance, let's call it F. Fiesta distance in centimeters, where it might collide with Corolla. So it might do it after 50 centimeters, is in the middle, or after another 100 centimeters, so after 150 centimeters, or after another 100 centimeters, after 200, which would be 250 centimeters, and so on. Those are the points at which it might collide with Corolla. How long would it take to reach each of these points? So T for time in seconds. 50 centimeters. So what's the time? The distance is 50 centimeters divided by the speed, which is 10. 50 divided by 10 is 5 seconds. And what's Corolla's distance going to be then? I think you might see the answer already. Corolla travels at the same speed. So it's also going to have traveled 50 centimeters after 5 seconds. In other words, this is the point where they collide. It might be fairly obvious from the diagram. They're going at the same speed, so they're both going to go bang. Oops, I didn't want to make it smaller. I don't know why I was waving my fingers. You can't see my fingers. It's all going wrong. They're going to go bang in the middle when they first get there, and that's after 5 seconds. So this is actually a relatively straightforward one. The answer is 5 seconds. I'm just going to put, how many seconds? I'm going to write 5 seconds just so there can be no ambiguity. In theory, you could just write 5 because it says how many seconds, so 5 is the number of seconds, but give the units. There's no reason not to. It makes it clear for you and for the person marking it. So this one in the end turns out to be relatively straightforward. But with long, complicated questions, often the first part is a relatively straightforward warm-up to get you into the key ideas, and then it gets a bit fiddlier. And so, ready for that? I'm going to blow my nose. And then I'm going to go on to the slightly more challenging things that await. So now, I start Fiesta at a speed of 10 centimeters a second, and Corolla at a different speed, but they're still in the same places. So the distances still apply. So Fiesta, let's do the same thing. So F distance. Look, we know this is in centimeters. I'm not going to write it on this time. F distance. So we know that Fiesta is going to be in the middle after 50 centimeters, after 150 centimeters, after 250 centimeters, and so on. We can add more columns if we need them later. I've spaced them out quite a lot just to make it clear for you guys. You might not want to space them this much in case your answer needs to go on. I can see there's a bit of fuzz turning up in my background, so I'm just going to strengthen my light a bit. Does that deal with it? Yes, it does for now. I guess that's a sign of it getting darker outside, needing more internal light. Okay. So that's Fiesta's distance. Now, what time has passed? Well, this is the same speed that we dealt with before. So the first time in seconds is going to be 5 seconds. 50 divided by 10. For the second one, divided by 10 is 15 and 25. So after 5 centimeters, Fiesta's in the middle. Fiesta's back to the middle when 15 centimeters have elapsed. Is back to the middle again when 25 have elapsed. It's going to be every 10 seconds. We can see that, which makes sense because going at 10 centimeters a second has to travel 100 centimeters each time to get back to the middle after the initial one. So it makes sense. It's going to go up in 10-second increments. That means steps. Now, what about Corolla's distance? So our Ford Fiesta is, or model thereof, has gone 50 centimeters, then 150 centimeters, then 250 centimeters to reach the middle. So the question is, that's when Fiesta is in the middle. Where is Corolla at each of these points? And how will we know when Corolla is in the middle? We'll know that Corolla is in the middle when we have a distance that ends in 50. Because remember, let's go back to the picture. We know that, and don't forget it's the same for Fiesta and same for Corolla because they're each starting halfway along their sides, that after 50 centimeters, then 150, then 250, then 350, and so on, the cars are in the middle. And we know that Fiesta is in the middle at every distance ending in 50. 50 centimeters, oh, sorry, that's the previous one. 50 centimeters, 150 centimeters, 250 centimeters. So when we find that Corolla is at a 50 distance, then Corolla is going to smack into Fiesta when it's at a 50 distance at the same time that Fiesta is at a 50 distance. It doesn't matter if Fiesta has travelled 150 centimeters and Corolla has travelled 950 centimeters because they've ended up at the same point. It's just that Corolla has gone faster and gone to and fro more before they collide. So we're just looking for a distance where Corolla has a time when Corolla has reached a 50 distance, if Corolla gets there at all. We need to find a distance. Let's look at our triangle. Distance is speed times time. It's times across the bottom. D equals S times T. Let's write that here as a note. D equals ST, because of course you don't need to write times by. So the speed is 20. So I'm not going to write all these out as separate calculations. I'm going to do them mentally because it's relatively straightforward. 5 times 20 is 100. That is not a 50 distance. We need to carry on. 15 times 20 is 300. I'd times it by 10 and double it. Not a 50 distance either. 25 times 20 is 500. And now we can see this is going up in 200 centimeter increments. Corolla is never going to be in the middle at the same time that Fiesta is in the middle. Whenever Fiesta is at a something and 50 distance, Corolla is at a something 100 distance. So they're never in the middle at the same time. They're just, oh, can I do this? You know, they're just kind of passing each other. God, it's really difficult. They're just passing each other like ships in the night. Good cliche. And yeah, never ever collide, because this is always going to go up by 100 at a time. This is always going to go up by 200 at a time. This will always be 50 something. This will always be 200 something. Yes, Corolla is sometimes in the middle, and when it is, Fiesta is somewhere else. So the answer to this one is a very simple, if we look at what the question wants to know, how many seconds will pass or state that they will not collide. The question has told us what to write. We need to write will not collide. Perhaps that wasn't completely clear, but fortunately these videos stay up on YouTube, so you can go back, you can rewind, you can go through that again, you can pause it as many times as you like as you work through the question yourself and try to work out what's happening at each point, and you'll get it. This isn't actually really the concepts. None of the individual concepts are difficult. The hard thing is sort of visualizing how it all fits together and what the logic behind it is. But I'm certain that you will all get there. Thank you for your very kind comments, people. Someone wants their fluffy cat to get a shout out, which is a really cunning way to try and get a shout out, but not quite cunning enough today. Not quite cunning enough. I'm on to you. And now the numbers get horrible. We have a 17. And Fiesta speed has changed to 5 centimeters a second. So this is nasty. But think about how questions like this are structured. They tend to build up your skills. First of all, we just learn a concept with a fairly simple question. Then we apply the concept in a slightly fuller, slightly more complicated question, but where the numbers aren't too tricky. Now, we've got very much the same structure. The cars are starting in the same places, but we've got more awkward speeds. But we know what to do with that now. We've got our table. We're going to do the same thing, but we're just going to have to be a little bit more careful with the fiddly numbers. One thing I would say is that the previous answer was will not collide. I think it's fairly unlikely that this will be a will not collide. I reckon there's a good chance that we'll have a collision somewhere. And if I don't get a collision, I'm going to check my numbers again in case I've made a mistake. It's perfectly possible that it's also will not collide, but on balance, I reckon it probably isn't going to be. I mean, I would know this, wouldn't I? I set the paper, but if I hadn't set the paper, that's the way I would be thinking. Okay, I start Fiesta at a speed of 5 centimeters a second. Now, we know where Fiesta is when they could collide. The same applies. So let's do the same thing again. They can only collide when at least one of the cars is in the middle. So let's do Fiesta. You could do it the other way around. You could do Corolla. But I go with Fiesta because it's the slower one. So we could find loads of points where Corolla's in the middle, and it's pointless because Fiesta hasn't even got there yet. So it makes sense to work with the slower car first. So Fiesta distance, after 50 centimeters, it's in the middle. After 150 centimeters, after 250 centimeters, don't worry, centimeters, but I've started now, and so on. We can add more columns if we need them. Yes, I've got my cheat sheet on the right to make sure that I don't make any really embarrassing mistakes, but I'm not just copying it, I am working it out as I go. Right, the time. What's the time in seconds? Oh, let's put seconds. Why not? So 5 centimeters a second. We need the time. So time is distance divided by speed. Okay? So the distance is 50 divided by the speed of 5. 50 divided by 5 is 10. We can do this mentally because it's quite easy to do, to divide things by 5. 150 divided by 5 is 30. 250 divided by 5 is 50. So now we're at 10, 30, 50 seconds. You can see where the sequence is going. It's going to be 70, 90, 110, and so on. But let's not go that far. Let's see what happens with our corolla. So c distance. And again, what's the distance? So d equals speed times time. D equals st. So the speed is 17. So we need to do speed times time. So 10 times 17, nice easy one to start with, is 170. Okay? And remember, we're looking for a point when corolla is at a distance ending in 50, because at all the distances ending in, Fiesta is always at a distance ending in 50, in other words, in the middle, after these time intervals that we're looking at, 10, 30, 50, 70, 90 seconds. So we just need corolla to be at some distance ending in 50. 170 is not that. To 10 seconds, 170. So after 30 seconds, it's going to be 3 times as far. 3 times 17 is 51, so it's 510. Still not there. Okay. 17 times 50. Well, this isn't too bad because we can do it times 100 and half it. So times 100, 1,700. Half that, 850. Pull out your party poppers. We've got the answer. 850 centimeters. So it doesn't matter that Fiesta hasn't traveled 850 centimeters. The point is that Fiesta is currently in the middle, because after 250 centimeters, Fiesta is in the middle. And after 850 centimeters, corolla is in the middle. Corolla is much faster and has traveled much further, but they're now in the same place. And when two moving objects are in the same place, you have a crash. And that is what we have here. The question asks what time it takes, and the answer is 50 seconds. So this one looked horrible, but in fact, I don't think it was significantly harder than the previous one. In some ways, it's easier because you don't need to work out that they'll never collide. You just need to find the point when they do. It's just that the 17 centimeters per second speed is a little bit awkward. But once we take that element out, it's really not too bad. But this question has always been building up. Belle Wu, don't think that just by paying me compliments you can get a shout out where I mention your name. It's not going to work. Okay, now we get to what it's all about, which is a significantly more challenging part of the question. But this is going to use the skills that we've developed. It will almost always use the skills that you've developed so far, but with some kind of twist. Okay? So, Fiesta is going here. Fiesta is 80 centimeters from there, so 20 centimeters from here. Let's just put that in too. And again, we got the same thing. So now they are not starting halfway along each side. Now, what made the previous questions easy was that we knew that the cars reached the middle at every distance ending in 50. 50 centimeters, 150 centimeters, 250 centimeters. That no longer applies. So, we need to start off by working out when our cars will be in the middle. And let's just take some notes there. So, Fiesta in middle when, no, we don't need to write complete correct sentences. Fiesta in middle, no, let's not put when, let's say after, let's at least make a slight gesture to being correct. So, the collision point is here, which is 80 centimeters. Oops, 80 centimeters from there, and that's 20 centimeters. And likewise here, we've got 80 centimeters and we've got 20 centimeters. I'm writing on a glass screen, that's why it's so extremely messy. Try to make it a little bit clearer in your own working, or you're going to get really stuck. Okay, so Fiesta is in the middle after 20 centimeters. And then Fiesta has to travel along here, 80 centimeters, and back another 80. So it's another 160. So it's going to be 180. I'm not going to write centimeters in it, which makes it confusing. So we got 180, and actually I'm not going to space it out as much because I want to fit a few more numbers in. 180 is back there, then has to go 20 and 20, so that's another 40. Okay, 220. Then is going to go 80 and 80, so that's another 160, so 280, 380. And, well, let's leave it there for now. Okay, we can carry this on if we need to. Corolla is in the middle after. Well, Corolla follows the same principle, but the number's the other way around. Corolla starts with 80 centimeters, so is in the middle after 80 centimeters. You can see this distance here. Then 20 and 20, another 40, 120. Then 80 and 80 back again, so another 160 is 180, 280. Then, then another 20 and 20, so another 40, so 320. Those are the numbers I got earlier, aren't they? Yes, they are. Very excellent. So these are the distances, centimeters, distances in centimeters, after which each car is in the middle. And we need both cars to be in the middle. So we need a point in time when both cars have covered a distance that puts them in the middle. Okay? Now, Fiesta is slower and has the shortest distance to get to the middle in the first place. So let's start with Fiesta. So we got F distance. We're going to do exactly the same thing. We just needed to do that prior step to work out when the cars are in the middle. Having done that, I think you'll find that it isn't really much trickier than what we've done before, but it was that step that was the extra challenge here. So Fiesta distance, 20 centimeters. Now I've got no idea whether these cars are going to meet or when, so let's work out for each one. So 20 centimeters, 5 centimeters a second. So the time, we need time, speed, distance, time. Time is distance divided by speed. Oops. T equals d over s. So 20 divided by 5 is 4 seconds. Okay? Time in seconds. Let's put our units in. Why not? Just to make it clear. Distance in centimeters, it would be clear if my handwriting was legible. And time in seconds. So after 20 centimeters, Fiesta is at the potential collision point, let's call it that rather than the middle, and 4 seconds have passed. Where is Corolla after this time? C distance. Okay, and distance equals speed times time. So Corolla's speed is 80 centimeters per second. 80 times time. 4 times 8. 80, 160, 320. 320 centimeters. 20 is a point when Fiesta is in the middle. 320 centimeters is a point when Corolla is in the middle. We've already found the first point where they collide. What's happened here is that Fiesta has spent 4 seconds dawdling from this point to this point. In those same 4 seconds, Corolla has gone whiz, 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 and back to the middle. Just in time for a spectacular smash. And this is the answer. The answer is actually surprisingly straightforward. They will collide after 4 seconds. Now, in the past, I would have repeated a lot of that to make it clear now. But I'm trying to make these lessons shorter, more bite-sized, less off-putting for people who don't want to sit around for 45 minutes or an hour. So I'm going to call it a day there and instead remind you that these lessons stay up on YouTube. So you can rewind, you can rewatch that explanation as many times as you like until it's completely clear to you. Also remember that the worksheet is always linked in the video description, so you can print that off, have it next to you, try things out until it all comes clear. Now, this exact question will probably not turn up in your 11 plus exam. It's quite quite an idiosyncratic question that I came up with. I think I invented this myself without sort of taking the idea from anywhere very closely. But it's the kind of speed, distance, time question that can come up. You get a lot of questions about things like trains leaving stations, when will they pass? They tend to say pass rather than crash into each other, so it isn't too traumatic. That's really common. A race where things catch up with each other, or things running from opposite ends, when will they meet? You find a lot of scenarios in exams that have a lot in common with this question. But the fundamental of it is this speed, distance, time triangle that we looked at the start. Remember this triangle up here. Learn it, get to know it, become intimately familiar with it. It will serve you very, very well through the rest of your school career. But also, this is one of those bits of maths that will help you a lot in adult life, because actually working with speeds and times and distances, being able to estimate them, being able to calculate them properly, this is the sort of thing that you will find yourself using quite often. So it's definitely worth learning, not just from an 11 plus point of view. All right, people, thank you very much for your participation. Oh, Zena really wants to do questions. All right, we will do just a small number of questions very quickly in exchange for you allowing me to do a very quick bit of publicity, and to remind you all, just for those few people who don't know, that I now do online classes, and they're really fun, and they're very active, and they're massively interactive. They are not on YouTube, they're on Zoom, so everyone's talking and shouting over each other and having opinions and teaching each other and learning as a group and making friends. And you can find out about those lessons on my website on the tuition page. Just go to the link down below this video. And if you aren't sure, try a lesson. Just try one lesson, see what it's like. And if it isn't for you, then you don't need to do it again. I won't bully you to join, but it'd be wonderful if you at least tried a lesson out. I would love to see you. Okay, right. That's my little plug. And in exchange for that, I'm going to take some questions. But I'm going to do this really quickly, so I may not take all your questions. Bella says, Robert, you should give yourself a shout out. I just did. I gave myself a shout out. That's another way of saying what I did. Right, okay. Ms. I says, how long should you spend on a question? That's an unanswerable question because it really depends. You need to have, through practice, essentially, you'll get a sense of when you're wasting time on a question, when you're staring at the page, when you're spending a length of time that isn't in proportion to the marks available. You'll know that feeling where you're kind of staring and just nothing's coming. And you need to find strategies to avoid that. Strategies include skipping the question and coming back to it later. But perhaps more practically, for how you actually get through that and don't end up not having to do that, you start to learn things like just writing down what you know and then working out what you can do with that. And things like that can really, really help you when it comes to timing your questions in an exam. There are some useful rules of thumb, but you shouldn't treat them too rigidly. So for example, it's very helpful to take the kind of a speed, distance, quiet time point coming up. It can be very useful to work out the number of marks available in the paper and the amount of time that you have, and work out how much time you have per mark. Time per mark. The amount of time divided by the number of marks in the paper. And then you can say for that, okay, so I've got about 45 seconds per mark in this paper. And that means you know that if you have a 5-mark question and you've spent 6 or 7 minutes on it, that you're using up time that you're going to have to make up somewhere else. And so maybe that's the time to leave this one and come back to it. But a very important follow-up bit of advice, never leave a blank answer space. You must come back to the question, and you must at the very least jot down a few ideas, because they can get some marks, and that will often make the difference between passing and failing. Never ever leave a blank space. Okay, right. Rashmi says, how old are you? Long-term visitors to the channel will know the answer. I'm 84. Are SATs easy once you've done the 11 plus? I actually know remarkably little about SATs because they're such a completely pointless exam. So ask somebody else, but I'd be inclined to say yes, they are quite likely to be relatively easy if you studied properly for the 11 plus. How long should you practice for each day? An absolute classic question. There is no answer to this. You need to find a rhythm of work that doesn't bore you. Everybody has to deal with some boredom. So, you shouldn't say, oh, I'm bored, I mustn't work. It's not allowed. Robert said not. But in general, if you're just getting incredibly bored every time you study and you can't focus, then you're probably studying too much because you aren't learning. But you also should push yourself a bit to improve your concentration skills. So it's a length of time where you can learn effectively, where you're still absorbing well. It's also about how many breaks you give yourself. You also want to think about how often, how many days in a week you study. Again, that's going to depend on you. You're old enough now to work out, what your particular, psychology is, what kind of balance of study and rest and other things you need. How much you need to keep going with your hobbies and clubs. I would tend to say all of them if possible, because your life is important. There's always going to be some reason to ditch them. You need to find reasons not to ditch them. You've got to fit these things in. And around that, you've got to fit your 11 plus work. So don't overdo it. Do an amount that you can sustain and where you're learning well, and you will find what that is. I'm sorry I can't give you a clear answer, but that is the only true answer. Someone said, what are your favourite colour? I would merely encourage you to look at the screen in front of you and have a guess. Will we get any kind of these questions in the 11 plus exam? Asks Ohio Final Boss. That is very, very Generation Alpha. I thought Ohio was an insult, though. Anyway, will we get any kind of these questions in the 11 plus exam? Questions of this difficulty, yes, if you're setting a more challenging exam. So, for example, for a more competitive independent school, for example, sometimes they set some really nasty ones at the end of the paper, 1 or 2 questions. It might be a bit like that. If you set the exam for St Paul's Girls, yes, you can expect things of that level of difficulty in Part C of their paper, just for instance. I'm going to finish in a second. How to maintain timing, I've addressed that already with an earlier answer. Zena, this is the last question I'm going to answer. How do you get better on a subject you struggle on? Because it's a good question. There are many answers to this, obviously. But one thing that you can start with is don't think I struggle with this subject. Because you can't revise a subject. How do you do that? How do you sit down and learn maths or English? Impossible. You need to break down as precisely as possible what you struggle with. And the more precisely you can identify exactly which things cause you difficulties, the better placed you are to address them and to solve your problems. And that's what I would advise you to do. Right, I'm going to end there because otherwise Mrs. Lomax is going to get annoyed because either she's cooked some dinner or she needs me to cook some dinner. And in either case, I shouldn't be up here talking to you. So I'm going to say goodbye. It's been fantastic to have you. Do try out one of my lessons. I would love to see you go to the tuition page on my website. And apart from that, goodbye and see you not next week because I'm away, not on holiday sadly, but I am most definitely away. But hopefully the week after that, I will see you for another live lesson. All right, bye-bye everybody. Thank you so much for joining. See you again soon.